Okay. I want to go over some stuff that could potentially or is on the test tomorrow. So I'm going to start going through that. Um, if you want to watch this anytime tonight, okay. Let me just email Hudson, who is asking what to study. Okay. So what do we need to know? We need to know the customary system. And right now I am just writing down the vocabulary from 01. Unit of measure, centi, deci, kilo. Okay. The customary system, that is the US system of measurement for like volume, weight, etc. A unit of measure is something like a mile, a kilometer, an inch. These are all units of measure. And centi, deci, kilo, these mean 100, or typically 100th. Deci, which is 10th, and kilo, which is 1,000. So a kilometer is 1,000 meters. So if you have 1 meter and you want to turn it into kilometers, that is, well, it's going to be 1,000th of a kilometer. It gets scaled down because kilometers are a lot bigger. These are the same. Okay. What else? You need to be able to convert within customary system and within the metric system when given a table. Okay. That's just basic, but we want to be looking more at level 3 because there's harder problems than that. You just need to be able to convert the metric units by using the tens rule, right? So here we divided by 3 tens. If I want to turn 1 kilometer into meters, that's going to become 1,000 meters. I multiply it by 1,000. It's just multiplying by tens. You also need to know, let's see, the 12, 3, 1760 rule, right? So these are going to be conversions when we're going from inches to, sorry, drew this diagram a little wrong because the numbers are not the nodes, those are the arrows. So inches, feet, yards, miles. 12, 3, 1760, of course, with miles being the biggest. Should we be taking notes on that? Right now, I'm referencing the proficiency scales, which are what's going to decide what's on the test. So I'm just going through everything in the proficiency scales, and you should be doing the same. That's exactly what you should be studying, what you should know. However you need to study that, it doesn't have to be taking notes. I would highly recommend flashcards, but you need to know everything on the proficiency scale. And right now I'm just looking at the very first one. You also need to know the 8224 rule, right? 8, 2, 2, 4. That's the next thing on the proficiency scale. Let me see. If I can share that with you. Or do you know where it is? Okay. Well, I'm going to continue. So we have the 8224 rule, which is going to tell us that there's between fluid ounces and cups, and then pints and quarts and gallons. This is how they grow. So gallons are the biggest, yeah? So if I had 16 cups and I want that in gallons, so how much bigger are gallons? Well, they're 4 times 2 times 2. They're 16. So 16 cups is exactly 1 gallon. Okay. That is simple conversions. Let's look at something that was like a little more complex. So we have 14 meters per second, and we want to convert this into something we can read. So we usually tend to understand speed in miles per hour or kilometers per hour, which is not meters per second. You might get a feeling of meters per second if you've looked at a lot of them, but if you haven't, and wait, is my screen not updating? Oh, I see. It's not caught up with the live stream. Okay. So if we have 14 meters per second, we want to turn this into miles per hour or into kilometers per hour. So how are we going to do that? So first, it's pretty easy to turn meters into kilometers. 14 meters over seconds. Well, we can multiply that like 1,000 meters in 1 kilometer. And now when we multiply all these out, these are going to cancel like in fractions. And now we have kilometers per second, but we need to convert the seconds. So let's do that. So we have 14 kilometers every 1,000 seconds. Okay. Even from this point, you might get the feeling that this is pretty fast. But we can convert it further by changing seconds into minutes. So there's 60 seconds in 1 minute. So that cancels. And there are 60 minutes in 1 hour. Now we have it into kilometers per hour if we can just compute, what is it, 14 times 60 times 60? over 1,000 hours. Okay. We can compute that on the calculator, but we're going to find that that is pretty dang fast. Where is my calculator? Give me just a second. Okay. 14 times 60 times 60 divided by 1,000. Okay. On my calculator, that says it is 50.4 kilometers per hour. Okay. And yeah, luckily, when we're in kilometers, that is pretty easy to get into miles by our quick and easy estimation, which is in the next rule, or in the next proficiency scale on 0 2, which is to know the 1 to 1.1 rule for meters to yards. Okay, so if we start over, see, when did we last have it in meters? Oh yeah, we had it in meters over here. So we had it at 14 meters times 60 times 60 is meters per hour. And sorry guys, not feeling super great. Okay, if we have 14 meters times 60 times 60, we got rid of the dividing by 1,000 up here because we're still leaving it in meters. We haven't converted it to kilometers yet. But we can convert meters into yards using our handy 1.1 rule. So we've got 14 times 60 times 60 times 1.1 yards. And then remember that yards are a lot smaller than miles, so we get 1760 yards is equivalent to 1 mile. Cancel, cancel. And we're going to put this in our calculator, 14 times 60 times 60 times 1.1. And that's 55440 miles over 1760 still. I do one more calculation of this and I get I get 31.5 miles per hour. Okay. And this is just by calculator. So knowing the rules allows us to construct these fractions where we can cancel out units and we can do conversions that we want. So this is just equal to 1 because 1 mile is the same as 1760 yards. Going back up to the top here, 1 kilometer over 1,000 meters. This is just 1 because 1,000 meters is 1 kilometer. 60 over 1 is just 60 seconds over 1 minute is just 1. 60 minutes in 1 hour, these are the same, so this is just 1, right? Whenever you have a number that's the same over a number, and when the numbers are unitless, they actually have to be the same number, that's just 1. So when we add units, we can have a different number, but it still be the same value, right? 60 minutes is just as long as an hour. 60 seconds is just as long as a minute. 1 kilometer is just as long as 1,000 meters. Okay. And this brings us to our next vocabulary word. Everything I've been doing here is on our next proficiency scale. So if you're reading along, and you should be, 0 to, right? We need to know dimensional analysis. That was what I was just doing with the canceling of units to do conversions. It's also used to check equations to make sure that we have the same units on both sides. We also need to know a ratio, which is really just a fraction. That's what a ratio is, simply. And proportional. Two things are proportional if they just vary by a fraction, right? So why are we introducing these at the same time? If we go back to the last page, right, I set up a certain ratio to help me do dimensional analysis. And all these units are proportional to one another, right? So we can use them to measure one another, and we can always create these fractions. That's what it means to be proportional. So if I have two variables, x and y, and they are in proportion, or actually let's do y over x, well then they should be able to equal some number k, which is just really a fraction a over b. That's what it means for two variables to be in proportion. They're equal to some fixed fraction a over b. Okay. So, given a conversion table, we need to be able to convert directly between customary and metric units. I'm not going to do that. I think that's a little straightforward. It's a little harder when we have to remember everything, but if you need to practice that, go get a table from like literally look up conversion from metric to customary and practice doing some conversions exactly. Okay, simple probability is our next section. And let's again go through all the vocabulary. Experiment, trial, outcome, event, probability, theoretical probability, and remember I gave you the definition for all of these in the Edpuzzle videos. Okay, also experimental probability. And finally, odds ratio. Okay, an experiment in math class is some random event that allows for different things to happen. When we allow an experiment to run one time, that's called a trial. A specific thing happening in the experiment is called an outcome. Some collection of things happening, or some collection of outcomes, is called an event. The probability is the number of possible outcomes over the number of possible ways an event could occur. That's the probability of an event. The probability of an experiment explains all these the probabilities for each event. The theoretical probability is when we compute the probability just purely using mathematics. But the experimental probability is when we run the experiment, we measure it, and then we try to infer what the true probability is. So theoretical probability is the true probability. The experimental probability is what is observed. Okay? Actually, I'm not going to put true in quotes. It's when we speak of the probability, that's what we're referring to. An odds ratio is a way of referring to a probability that isn't divided by the size of the number of all possible events. An odds ratio more is like good versus bad outcomes. So if I have 8 chocolates and 2 have toothpaste, what's the chance I get a chocolate with toothpaste? Well, it's not, the probability is 2 out of 8, but the odds ratio is the good, or the event to the non-event. So 2 chocolates have toothpaste, there are 6 chocolates left. This is the odds ratio. Okay. What about some of the things we have to do for simple probability? Well, we just have to compute simple probability. I'm not going to ask you anything difficult, but I may ask you to express it as a probability, as a percent, as a fraction, right? Or as an odds ratio of good to bad outcomes. That's what level 3 is at. Okay? So if there's the jar problem, I don't think anybody had a problem with simple probability. It's just you need to remember what an odds ratio is, and then yeah. Okay. For number 4, for algebraic expressions, we have the order of operations. I don't care if you use PEMDAS, that's fine as long as you know what that means. You can also learn GEMA. If you know this in another language, I would love for you to teach me. But ours is groups, exponents, multiplication, division, addition, and subtraction. Okay. And this is left to right, left to right. And also in your proficiency scale, it says to avoid ambiguous expressions or ambiguous symbols like this, okay? So don't use the division symbol when you're typically doing it, okay? You need to be able to compute the absolute values of numbers. Okay. What is the absolute value of -3? It's +3. What's the absolute value of 8 minus 5? Well, we do groups first. Inside this group is subtraction, and 8 minus 5 is the absolute value of 3 equals 3. Okay. You also need to be able to consistently combine like terms to simplify expressions. So like 2x plus 7 equals 8 times x minus 3 plus 17x plus 2 to the 4th. Okay. So I've got this long algebraic expression. Let's do our orders of operations. So first we're going to compute groups. Okay, I see one group in this. I I can't simplify it though because it's a variable. So I'm going to check the next thing. What about exponents? Okay, I have an exponent here, so I'm going to simplify that. 2 to the 4 is 2 times 2 is 4, times 2 is 8, times 2 is 16. So that is 16. 17x plus x minus 3 times 8, 7 plus 2x. Okay. We're going to distribute because we're going to keep going down our Gima, and we have multiplication, and it's the only multiplication I can do. So when I multiply this, this becomes 8x minus 3 times 8, which is, I guess, 24, and plus 17x plus 16 plus 7, 2x. Dragging everything down. Okay, combining like terms, I can see that 17x and 8x combine. And I'm going to get, well, I can do, sorry, if I'm doing the order of operations, I need to do addition and subtraction left to right. But I can swap things around because this is really all addition, especially if I consider the subtraction as adding a negative. So this can just be 8x plus 17x minus 24 plus 16. Then I can keep simplifying this and get 25x combining like terms and not unlike terms. And then minus 8. And then plus 7, just dragging this all down, 2x. And I go minus 2x, and I'm putting it under the same like term, plus 8, plus 8. This is just all basic algebra stuff. We just want to be able to do the order of operations. Then divide by 23, divide by 23, and that gives us x. Okay, and that's even further than we needed to go. We just want to be combining like terms for this one, right? There's nothing in this about solving equations. But what, as far as vocabulary goes, we need to know Gima. We need to know order of operations, which is Gima. We need to know substitution, how we can substitute one thing for another. We need to know what like terms are. And we need to know how to use the distributive property with variables. Okay. Check the chat real quick. Evan, okay. Pull up Discord, Evan. Evan, can you send me a message? Okay, excellent. There we go. Okay, guys. Yeah, you send me a message on Discord, you can join a voice chat and we can talk about this live. Might be easier. Evan. Evan. um. Ugh. Are you are you sure? Okay. Then join voice B. Okay. What's up, Evan? This is better. Any questions for me? I've gone almost through the proficiency scales, but I haven't really described the stuff. Okay. All right. Evan says he doesn't have any questions. If anybody else, I see I have 3 viewers, so if anyone viewing right now wants to join voice and ask question, feel free. And Evan, I don't think your voice is being recorded, but do you have any questions about level 4 stuff? Yeah, did you look at the stuff above level 3 on the proficiency scale? Mastery level. 01, 02, 03, 04, any of them. Okay. Evan just asked me what are ambiguous expressions. And I'm going to talk to you in this weird way because the Discord voice channel is not being recorded, I don't think. Okay. So if you look up ambiguous expressions in math, you get something like this. I'm going to post this in the YouTube chat. There are things that are just kind of hard to read. Okay. So the example they give is 2x divided by 3y minus 1, x equals 9, y equals 2. So they're saying to evaluate this. So if we try to evaluate this, what do you get? Yeah, so for this we need to know substitution, right? So we're going to need to substitute in x, right? So let's, yeah, and we're going to want to use schema to evaluate this, right? Okay, sweet. I'm just trying to use our vocabulary words. The more you can use them, the more comfortable you are with them, the better. So what do you get when you evaluate this? You tell me. Do you know what the word ambiguous means? Ambiguous is when something is not clear. So at this stage, Evan, did you feel it was clear what you were supposed to do? It was clear? What, but why was there the hesitation? Right? Doesn't it feel like this goes together? Right? So you're like, well, you just evaluate it left to right. This expression is ambiguous because it could be written two very different ways and both feel correct. So I don't want you to write your math like this because it's not clear. It's ambiguous. This is going to be one of two things, right? It's either going to be 18 over 3 times y, which is very different from 18 over 3 times y, right? Or, worse still, this could be 2 times x over 3 times y, which would be kind of silly if they wrote it this way, right? So we want to write our math like this so it's very clear what's going on, or like this, and not like this. That's the whole point. Because even though, yeah, you can follow Gima, if you're writing math for both yourself to understand or other people to understand, you want to write it as clear as possible so that Gima is almost like, kind of an afterthought, right? Yeah, that's kind of the idea. But sometimes we need to rely on Gima when, expressions are really complicated and it would be harder to simplify them. Okay. Any problems with conversions? No, you didn't, but I'd love to talk to someone who had problems. Would you know what dimensional homogeneity means? Let's break down this word. What are the origin of those root words? What do they mean? Okay, that's fine. That's why I'm asking. I just want to see if you remember. Homo means same. Geneity. What do you think? Come on. Um, it's not super obvious, but we are in an Adventist. Does this word look like anything? Sorry. Okay. Now what does that word remind you of? The beginning. Um, so in this case, in this context, we're talking about like the same nature or the same kind. Homogeneous means they're all the same, right? So when we have in this, I'm looking at the level 4 for 0, 2. Explain when equations have dimensional homogeneity and what it means when an equation fails to have dimensional homogeneity. So now when we include this word dimension, and when we're talking about the type of dimension, we're talking about the types of units. How we're going to measure things. Are we talking about volume? Are we talking about length? Um, Let me just check the last test if there was anything that very sick right germs, I assume. Okay. Um, yeah, the odds ratio question, the order of operations, experimental probability versus theoretical probability. You clear on that? Really, any questions about definitions? The vocab heavy class. Well, read over the words. Rewatch the Edpuzzle videos if you need to refresh those words. You can also like look up math is fun or anything else. But yeah, it's all on the it's all in the proficiency scales. You should use it like a checklist to mark off everything you know. You should know how to say like and describe every single vocabulary word. Know them like friends. Because I'm going to keep using them in class all the time. Okay. I'm going to log off so I can do a stream for Algebra 2 because they need it as well. And no one is in the YouTube chat, although there are other viewers. But if you have any questions before I end the stream, please ask. Got any other questions, Evan? Okay, your first test was pretty dang good. Just I hope you haven't forgotten anything. Okay. Night, Evan.